We are excited to share with you our latest platform, ZAP, which connects, integrates, and automates your workflow process in advanced manufacturing. Our platform is purpose-built for advanced manufacturing, combines aspects of MES, PLM, CRM, ERP, and QA with full traceability that drives the optimization and efficiencies our customers demand. Please join us while our founder, Anton Vedishin, and CTO gives you a demonstration of ZAP and its full capabilities.
Anton Vedishin, I'm the CTO of 3D Control Systems, and today I'm going to show you the latest advancement in our technology. So this is the MES system, which actually has many different modules, and it's fully customizable. It's enterprise software. So it has the dashboard and business intelligence. It has the CRM, ERP, MES, quality assurance management, and many more. I'll start with the first part, the statistics analytics and the BI tool. So here are the examples of graphs which show parts produced, target versus actual, then on-time delivery, target versus actual, operational efficiency based on the formulas that I used in a certain enterprise. Then we show the utilization graph, and I can drill down by different dates, see different locations, see different machine at these locations and its utilization. We also show total spend per day. In case of service bureaus, it could be revenue per day. Also, you can drill down deeper and see. We can show different deeper analytics. On the left-hand side, I have different order numbers, and then the most common parts inside those orders, the most common manufacturing materials used to manufacture those parts, and the most used post-processing techniques. And this gives a good overview to decision makers, engineers, whether they need to set up another, let's say, anodizing bath, or create another powder painting corner in the lab, or maybe get rid of some equipment. Now let me move to the CRM part. So in the CRM we have quoting, and I have here different quotes. I can create a new one. User can select different technologies, material types, application types, service types, post-processing techniques, and QA techniques. We support different file formats, STL steps, OBJs, CAD formats, and many more. And this part could be embedded into the website, where users, without even logging in, can drag and drop files, get quoting instantly, and basically get parts produced. Then there is a customer list, and for each customer, the monthly spend, the total spend, number of orders, and I can go deeper and see what's happening there. If I go to orders, then I can see all the orders in the system, and I can go to some orders and see what's happening there. Like some parts already produced, some not yet. We have such thing as a part passport. If I click here, I can see all the steps the part went through during manufacturing, and we collect here all the data about this part. So the position of the part and the build volume, the rotational matrix, it's pretty important for powder machines. We show the car codes, and we show all the data on the process. So for example, who was ordering the part, who scheduled the part, what was the build file name, who was manufacturing the part, who was the machine operator, what material was used, what were the powder mixtures and the producers of this material, and then different post-processing steps, like who exactly was removing the supports, who was sintering the part, for example, or in case of QA, it could be caliper measurement, CMM, 3D scanning, dynamic balancing, destructive tests. And at each step, user can attach the corresponding files. Let's say at QA, some measurement results. In case of post-processing, maybe some pictures or surface tolerances. Manufacturing, the material certificates, and if these materials have certificates attached, they would come here automatically. We also link data to the blockchain, so data is immutable over time. And we also collect a lot of data from the machines, like O2 level from inside the chamber temperatures, humidities, and we also can collect data outside of the machine, so basically in the lab or in the room where machines are or material is. Now I'm moving to the ERP. So here I have the HR module. We can do the payroll, calculate hours, the orders already showed, inventory. Basically this is the place where designers push the latest versions of the most common parts used in the enterprise. Of course, it depends on the enterprise. In this setup, this would be the inventory of an automotive company, for example. So they have a list of qualified parts. I can preview the files. I can see how it fits the build volume for different machines. So I can move it into the middle. And I can go to different machines here and see how it fits the build volume. We also do the geometry analysis, so I can see are there any mesh holes or mesh intersections. Okay, this one is clean. We also have a tool to cure the parts and fix this type of issues. For FDM machines, for example, I can slice and print right away. I don't need to nest them, but for other technologies, I would nest. So from here, I can add parts into the basket, like this. And go to the basket. This like an internal order. So here, I see the technologies, I can switch to, let's say, CNC milling or something else, and the price will adjust accordingly. I can also go for different applications. Let's say for tooling jigs fixtures, it should be more precise, prototyping. Then we can manage also the outsourcing partners. Let's say if I want to make this part through the outsourcing partner, the price will be higher, the date will potentially go down. I can add post-processing techniques, so some techniques can come with the material or with the technology, and I can add more, and the price obviously will increase. And I can do the same with the quality assurance. Could be as simple as caliper measurements, so CMM, 3D scanning, destructive tests, dynamic balancing, so the price increases here. And we have the different connections to delivery companies, or it could be just local pick application, the due dates. And when I order this, then it goes next to the manufacturing execution system. We also have a way to keep track and version controlling of different projects. So here I have the projects, and I can basically see what are the parts, the files. It can have multiple hierarchy. I can attach a process here to the part, and let's see. So to the whole project, attach the workflow. If you want to manufacture it with, let's say, metal or nylon, something like that, I can create a new workflow. This will attach the process to the file or the project, and then basically it will be executed in the MES. We have different CAD integrations, so engineers can go directly from Solid Edge, SolidWorks, Fusion 360, Inventor, Rhino, CATIA, Space Claim, so many different softwares. And we also have unique price settings, which allows to set up basically everything depending on material, the application, and so forth. So it's useful for companies because they can set up exactly how they price a bill, for example, today, and the pricing could evolve. So pricing in our case is not something which is like embedded into the system. Then the MES has packing. So here, when I upload parts, they go into the packing. I can prepare the build volumes. We have a unique technology to integrate different types of softwares, and we wrap the software into the special container, set up it on the server, and then basically people don't need to switch softwares and go to other softwares, export, import, and so forth. And this queue currently it's based on material, but it could be also set up by machine and material type, then machine type, and so forth. Or it could be just a global queue for the parts. Then in the assets, we have all the assets, basically the printers, the post-processing equipment, QA, and we collect data directly from the machines. We can do predictive maintenance like filter cleaning or laser maintenance at a certain time, and it's basically showing what's happening on the machines real time. In case of some machines, we can even see how much filament left there. Then the job scheduling. So as soon as the build tray is ready, I can drag and drop this into the queue, and I can see what's inside the build file, which part I can see them nested. I can print out the travelers, and we can generate car codes, labels for the parts in the build tray. And then after the parts are done, they go to post-processing. So here in post-processing, there are different queues here, and I can go to certain queue and see which machines are available, and I can schedule the parts for certain post-processing techniques. Say for support removal, I can schedule for automatic dissolver machine, but then maybe there are human resources who are doing supports removal, so I can schedule them too. This also could be done automatically. There is another way to manage parts through the Agile dashboard, where I can prioritize parts too. Then we have digital travelers, so I can see real time what's happening with the parts in the system, at which stage are this, and go deeper and see what's happening. Then we have machine drivers. We support different protocols, different technologies, so we can speak to almost all of the desktop FDM machines. And a year ago we started to integrate industrial machines, so now we have HP integrated, Stratasys. We're finalizing this, and in the pipeline Carbon, EOS, and more other brands. We have the workflow management, where I can basically create the workflows, manage them, and the material management. So here I have the list of different materials. I can add stock of material, select or part code scan the vendor batch number, attach the material certificate, select the material types, select different vendors, the colors, weights, estimated date, expiration date. So basically when it's going to expire, 90 days, 60 days, 30 days, we will notify the user. And if something expired, we also highlight it here. And then I can load this material into the digital twins of the machines and the assets. So basically we know what exactly, which material exactly was used to manufacture certain parts. And then the QA scheduling is very similar to post-processing and manufacturing. So here I have different parts, I have different stations or different people doing the QA, so I can schedule this the same way. And as soon as the part is done with one certain process or step, then it automatically goes to the next one. Then we also have APIs, so we can speak to other systems, and other systems can speak to our system, so it's fully interconnectable. And this is a very quick overview of what we have.